Hello, welcome again. We are covering the subject thermodynamics for civil services, MECH, IFS, and various gate exams. And now we have finished the derivation of variable or unsteady flow process. Now we'll take one example of variable flow problem and apply the system techniques and control volume technique to solve this. Suppose we are filling the bottle from the pipeline and subsequently we are supplying heat also. Okay. So here this can be solved by two techniques, that is system technique and control volume technique. In control volume technique we will take this control volume and this is a control surface. Okay. And in system technique we will take the envelope of the this envelope and this is the system boundary. Okay. And this mass is entering the system. Okay. So here first of all we'll consider the condition within the bottle before filling and represented by suffix 1, like pressure P1, temperature T1, specific volume V1, enthalpy H1 and internal energy V2. And after filling the bottle, so these conditions are represented by P2, T2, small V2, H2 and V2. And suppose M1 is the initial mass inside the bottle and M2 is the final mass inside the bottle. And this mass change is taking place due to this gas, whose properties are or pressure are Pp, temperature Tp, volume Vp, enthalpy Hp, and internal energy Up and velocity Vp. Or we can say the properties of the gas in the pipeline, that where P suffix is. Okay. So now if we consider system technique, then this is your system. Okay. This is your system, and this envelope of gas is coming into the bottle. It has some volume before entering and that volume after entering will collapse and the final volume will be 0. So will this is this will collapse and will enter the system. Okay. And now if we consider this system, then energy before filling is energy of this gas, that is M1 U1, plus energy of this envelope that is entering in the bottle. So that is your M2 minus M1, or mass of the gas entering the system, okay, or MT, and its velocity is Vp and internal energy Up. So that is Vp square by 2 plus Vp. Okay. So that is the mass, that is the internal energy of the gas inside the bottle, and that is the internal energy of the gas that is entering in the bottle. Okay. So that is total internal energy before filling, and after filling the final mass becomes M2 and final specific internal energy becomes V2. So total energy is M2 V2. Okay. So now this is so the change in energy is difference of this E2 minus E1. Okay. So that is M2 U2 minus M1 U1 and plus M2 minus M1 Vp square by 2 plus Up within bracket. So now if this P terms are neglected, where P terms are, we have not taken Z, we have taken only the kinetic energy and internal energy. Okay. So as also there is no P term within the bottle, assuming that the level of bottle remains same before and after filling. Okay. And there is no change in K or within the bottle. Okay. So this is the change in energy. Okay. Now this envelope when enter the system will collapse. It may have some initial volume, but finally it will have zero volume. This will. So now work done will be here because its pressure is Pp and final volume is zero, initial volume is V1. So the work done on making this envelope to zero volume is Pp 0 minus M2 minus M1. So 0 is final volume and this M2 minus M1 into Vp small Vp initial volume. So this will be your minus bracket M2 minus M1 bracket close Pp Vp. Okay. So this is the work and this is the change in energy. Now the heat that is applied to the system is Q, so that can be found by Q plus del E plus W. Okay. So this will be the expression for solving this. We will get Q as this one, so which gives the energy balance to the system. Now this is by system technique. Now by control volume technique, we have derived this relationship, that is dEV by d tau is equal to this inlet energy plus heat supply minus outlet energy minus work done. So if we take this control volume, so this in this there is no displacement of the volume. Okay. So there is no work done. Okay. So there is no work done. So work done term is omitted, and there is no mass outflow. So this term is also omitted. This work done, this is omitted. This is omitted. So we'll have this dq by d tau and mass that is coming in having some energy. So that is in the form of H and V. So there is no change, no potential energy or change in potential energy small that can be negative. So then this equation reduces to this part and this part and plus this part. This will be zero because there is no mass outflow, no work done. If we consider this as control surface or control volume, here there is no change in volume. Okay. So it will become dEV by d tau is equal to dq by d tau plus hp vp square by 2 dm by d tau. Okay. Or further we can write it as del EV q plus hp plus vp square by 2 m2 minus m1, because dm is the mass of the mass, that is mass product, that is m2. So that is change in mass, that is if we take final time, then it will be m2 minus m1 and this will be your q and it will be w. Or del EV is your u2 minus u1 or m2 minus small u2 minus m1 minus small u1, or q will be from this, q will be your m2 u2 minus m1 u1 minus hp plus vp square by 2 or into hp. Okay. So this will be a q.